Welcome to our deep dive into the fascinating world of sensors. Sensors are everywhere in our daily lives, from the smartphones we use to the cars we drive and even in our homes. But what exactly is a sensor? In simple terms, a sensor is a device that detects and responds to changes in the environment. It converts physical parameters like temperature, pressure, or light into signals that can be measured and analyzed. In this video, we'll explore the different types of sensors, how they work, and why they're so important in modern technology. Let's get started by understanding the basics of what makes a sensor tick. Sensor is a device designed to detect events or changes in its environment, and then provide a corresponding output, usually as an electrical or optical signal. Think of it as the senses of a machine, much like our eyes, ears, or skin. Sensors can measure a wide range of physical properties such as temperature, pressure, humidity, motion, and more. The information they gather is then used by systems to make decisions or trigger action. For example, a thermostat uses a temperature sensor to regulate heating and cooling in your home. Understanding sensors is key to unlocking the potential of modern technology. Sensors come in many shapes and sizes, each designed for a specific purpose. Some common types include temperature sensors, pressure sensors, light sensors, motion sensors, and proximity sensors. Each type detects a different kind of physical change and converts it into a signal that can be processed. For instance, temperature sensors are used in weather stations, while motion sensors are found in security systems. The diversity of sensors allows them to be used in countless applications, making our lives safer, more convenient, and more efficient. Let's take a closer look at some of these sensor types. Temperature sensors are among the most widely used sensors in the world. They measure the amount of heat energy in an environment and convert it into a readable signal. You'll find temperature sensors in everyday devices like ovens, refrigerators, and air conditioners. They're also crucial in industrial settings, where maintaining the right temperature can be a matter of safety and efficiency. There are different types of temperature sensors, such as thermocouples, resistance temperature detectors, RTDs, and thermistors, each with its own strengths and applications. Pressure sensors play a vital role in many industries, from automotive to healthcare. These sensors detect the force exerted by a liquid or gas and convert it into an electrical signal. In cars, pressure sensors monitor tire pressure to ensure safety. In medical devices, they help regulate blood pressure monitors. There are various types of pressure sensors, such as piezoelectric, capacitive, and strain gauge sensors, each suited for different applications. The ability to accurately measure pressure is essential for maintaining system stability and safety. Light sensors, also known as photodetectors, are used to measure the intensity of light in an environment. These sensors are found in devices like smartphones, where they adjust screen brightness automatically, and in streetlights that turn on at dusk. Light sensors can detect visible, infrared, or ultraviolet light, depending on their design. They are crucial in applications ranging from photography to scientific research, enabling devices to respond intelligently to changing lighting conditions. Motion sensors detect movement within a specific area. They are commonly used in security systems, automatic doors, and gaming consoles. These sensors work by measuring changes in position, speed, or acceleration. There are several types of motion sensors, including passive infrared, peer, ultrasonic, and microwave sensors. Each type has its own advantages and is chosen based on the application. Motion sensors help automate processes and enhance safety by detecting unauthorized movement or triggering alarms. Proximity sensors are designed to detect the presence or absence of an object without physical contact. They are widely used in smartphones to turn off the screen during calls, in cars for parking assistance, and in industrial automation. Common types include capacitive, inductive, and ultrasonic proximity sensors. These sensors improve user experience and safety by enabling touchless operation and preventing accidental damage to devices. Humidity sensors measure the amount of moisture in the air. They are essential in weather forecasting, HVAC systems, and industrial processes where humidity control is critical. These sensors help maintain comfort in homes and offices and ensure the quality of products in manufacturing. There are different types of humidity sensors, such as capacitive, resistive, and thermal sensors, each with unique features and application. Gas sensors are used to detect the presence of gases in the environment. They are crucial for safety in homes, workplaces, and industrial settings. For example, carbon monoxide detectors use gas sensors to alert occupants to dangerous levels of the gas. Other applications include air quality monitoring and leak detection. Gas sensors come in various types, such as electrochemical, infrared, and semiconductor sensors, each designed for specific gases and environment. Touch sensors are found in many modern devices, from smartphones to elevators. They detect physical contact or pressure and translate it into an electrical signal. Touch sensors can be capacitive, resistive, or piezoelectric, each offering different levels of sensitivity and durability. These sensors have revolutionized the way we interact with technology, making devices more intuitive and user-friendly. Sound sensors or microphones detect audio signals and convert them into electrical signals. They are used in a wide range of applications, from voice assistants and hearing aids to security systems and musical instruments. Sound sensors can be dynamic, condenser, or piezoelectric, each with unique characteristics. These sensors enable devices to respond to voice commands and record audio, making them essential in today's connected world. Image sensors are the heart of digital cameras and smartphones. They convert light into electronic signals, allowing devices to capture photos and videos. There are two main types of image sensors: CCD, charge-coupled device, and CMOS, complementary metal oxide semiconductor. Each type has its own advantages in terms of image quality, speed, and power consumption. Image sensors have transformed photography and enabled new applications in fields like medicine and security. Position sensors determine the location of an object in space. They are used in robotics, automotive systems, and industrial automation. Common types include potentiometers, encoders, and linear variable differential transformers (LVDTs). These sensors help machines move accurately and safely, enabling precise control in manufacturing and navigation systems. Position sensors are essential for automation and robotics, where accuracy is critical. Speed sensors measure the rate of movement of an object. They are commonly used in vehicles to monitor wheel speed in industrial machines and in sports equipment. Types of speed sensors include magnetic, optical, and Hall effect sensors. These sensors provide real-time feedback, allowing systems to adjust performance and ensure safety. Accurate speed measurement is vital in transportation and manufacturing. Force sensors measure the amount of force applied to an object. They are used in applications ranging from electronic scales to robotics and medical devices. Types of force sensors include strain gauges, load cells, and piezoelectric sensors. These sensors help ensure safety and precision in tasks that require accurate force measurement, such as surgical procedures or quality control in manufacturing. Magnetic sensors detect changes in magnetic fields. They are used in compasses, smartphones, and industrial equipment. Types include Hall effect sensors, magnetoresistance sensors, and fluxgate sensors. Magnetic sensors are essential for navigation, position detection, and security systems. Their ability to sense magnetic fields enables innovative applications in both consumer electronics and industrial automation. Infrared sensors detect infrared radiation, which is invisible to the human eye. They are used in remote controls, night vision devices, and temperature measurement tools. Infrared sensors can detect heat emitted by objects, making them useful for security and surveillance. There are two main types, active and passive infrared sensors, each with specific applications in electronics and safety systems. Ultrasonic sensors use high-frequency sound waves to detect objects and measure distances. They are commonly found in parking sensors, robotics, and industrial automation. These sensors emit ultrasonic waves and measure the time it takes for the echo to return, allowing for precise distance measurement. Ultrasonic sensors are valued for their accuracy and ability to work in challenging environments. Optical sensors detect light and convert it into electrical signals. They are used in barcode scanners, optical mice, and fiber optic communication systems. Optical sensors can measure light intensity, color, and distance. Their high sensitivity and speed make them ideal for applications that require fast and accurate detection of light changes. Biosensors are specialized sensors that detect biological information, such as glucose levels in blood or pathogens in food. They combine a biological component like an enzyme or antibody with an electronic sensor. Biosensors are widely used in medical diagnostics, environmental monitoring, and food safety. Their ability to provide rapid and accurate results has revolutionized healthcare and research. Chemical sensors detect and measure chemical substances in the environment. They are used in industrial processes, environmental monitoring, and safety systems. Chemical sensors can identify gases, liquids, or solids and provide real-time data for decision-making. Types include electrochemical, optical, and semiconductor sensors, each suited for different applications and substances. Radiation sensors detect ionizing radiation such as alpha, beta, and gamma rays. They are essential in medical imaging, nuclear power plants, and environmental monitoring. Common types include Geiger-Müller tubes, scintillation counters, and semiconductor detectors. Radiation sensors help protect people and the environment by providing early warning of dangerous radiation levels. Level sensors measure the level of liquids or solids in containers. They are used in industries like water treatment, food processing, and oil and gas. Types include ultrasonic, capacitive, and float sensors. Level sensors ensure that tanks and silos are filled to the correct level, preventing spills and optimizing processes. Accurate level measurement is vital for safety and efficiency in many industries. Flow sensors measure the rate of flow of liquids or gases. They are used in water meters, fuel systems, and industrial processes. Types include turbine, electromagnetic, and ultrasonic flow sensors. These sensors help monitor and control the movement of fluids, ensuring efficient operation and preventing leaks or overflows. Acceleration sensors or accelerometers measure changes in velocity. They are found in smartphones, fitness trackers, and vehicles. Accelerometers detect movement, orientation, and vibration, enabling features like screen rotation and step counting. These sensors are essential for applications that require motion detection and analysis. Gyroscopic sensors or gyroscopes measure rotational movement. They are used in smartphones, drones, and navigation systems. Gyroscopes help stabilize cameras, enable precise navigation, and improve the performance of virtual reality devices. These sensors are crucial for applications that require accurate measurement of orientation and rotation. Vibration sensors detect oscillations or movements in objects. They are used in industrial machinery, earthquake detection, and structural health monitoring. Types include piezoelectric, accelerometer, and velocity sensors. Vibration sensors help prevent equipment failure and ensure the safety of structures by providing early warning of abnormal vibrations. Tilt sensors measure the angle of an object relative to gravity. They are used in construction equipment, gaming controllers, and smartphones. Tilt sensors help detect orientation changes, enabling features like automatic screen rotation and stability control in vehicles. These sensors are essential for applications that require precise angle measurement. Color sensors detect and distinguish colors in objects or environments. They are used in manufacturing, robotics, and quality control. Color sensors help sort products, detect defects, and enable color-based automation. These sensors are vital for processes that require accurate color identification and sorting. Moisture sensors measure the water content in soil or materials. They are widely used in agriculture, gardening, and construction. Moisture sensors help optimize irrigation, prevent overwatering, and ensure the quality of building materials. Accurate moisture measurement is essential for efficient resource management and product quality. pH sensors measure the acidity or alkalinity of a solution. They are used in water treatment, agriculture, and laboratories. pH sensors help monitor water quality, optimize crop growth, and ensure accurate chemical analysis. These sensors are crucial for maintaining safe and healthy environments in various industries. Salinity sensors measure the concentration of salt in water. They are used in environmental monitoring, aquaculture, and desalination plants. Salinity sensors help maintain the health of aquatic ecosystems and ensure the quality of drinking water. Accurate salinity measurement is vital for managing water resources and protecting the environment. Smoke sensors detect the presence of smoke particles in the air. They are essential for fire detection and safety in homes, offices, and public buildings. Types include ionization and photoelectric smoke sensors. These sensors provide early warning of fires, helping to save lives and prevent property damage. Flame sensors detect the presence of flames or fire. They are used in industrial safety systems, gas turbines, and boilers. Flame sensors help prevent accidents by shutting down equipment when a flame is not detected or when an unexpected flame appears. These sensors are crucial for ensuring safety in environments where fire hazards exist. Rain sensors detect the presence of rain or moisture on surfaces. They are used in automatic windshield wipers, irrigation systems, and weather stations. Rain sensors help automate responses to changing weather conditions, improving safety and efficiency. These sensors are especially useful in vehicles and smart home systems. Current sensors measure the flow of electric current in a circuit. They are used in power management, battery monitoring, and industrial automation. Types include Hall effect, shunt, and transformer-based sensors. Current sensors help protect electrical systems from overload and ensure efficient energy use. Voltage sensors measure the electrical potential difference between 2 points in a circuit. They are used in power distribution, battery management, and electronic devices. Voltage sensors help monitor and control electrical systems, ensuring safety and reliability. Accurate voltage measurement is essential for the proper functioning of electronic equipment. Distance sensors measure the space between two objects. They are used in robotics, automotive systems, and industrial automation. Types include ultrasonic, infrared, and laser distance sensors. Distance sensors enable precise positioning, obstacle detection, and automation in a wide range of applications. Smart sensors combine sensing capabilities with data processing and communication features. They can analyze data, make decisions, and communicate with other devices. Smart sensors are used in the Internet of Things, IoT, smart homes, and industrial automation. Their ability to process information locally reduces the need for external computing and enables faster, more efficient responses. Wireless sensors transmit data without the need for physical connections. They are used in remote monitoring, environmental sensing, and wearable devices. Wireless sensors enable flexible deployment and real-time data collection in challenging environments. Their use is expanding rapidly with the growth of IoT and smart technologies. Sensor networks consist of multiple sensors connected to collect and share data. These networks are used in environmental monitoring, smart cities, and industrial automation. Sensor networks enable large-scale data collection and analysis, providing valuable insights for decision-making. They are the backbone of many modern technological systems. Sensor calibration ensures that sensors provide accurate and reliable measurements. Calibration involves comparing sensor readings with known standards and making adjustments as needed. Regular calibration is essential for maintaining the performance and accuracy of sensors, especially in critical applications like healthcare and manufacturing. Future of sensors is incredibly exciting. Advances in materials, miniaturization, and artificial intelligence are enabling new types of sensors with greater sensitivity and intelligence. Sensors will continue to play a vital role in emerging technologies like autonomous vehicles, smart cities, and wearable health monitors. As sensors become more integrated and connected, they will unlock new possibilities and transform the way we live and work. Summary: sensors are the unsung heroes of modern technology. They detect, measure, and respond to changes in the environment, enabling countless applications that make our lives safer, more convenient, and more efficient. From simple temperature sensors to advanced smart sensors, the variety and importance of these devices cannot be overstated. As technology continues to evolve, sensors will remain at the heart of innovation, driving progress in every field. Thank you for joining us on this journey through the world of sensors.